Howdy, howdy. Dylan with Huntsville Guns. Different subject matter for you today. I want to talk about the different types of manufacturing and specifically additive manufacturing in the gun space. So we've all seen 3D printed firearms. It's something that was kind of controversial and big in the news a few years back, relatively recently anyways. But I want to cover a slightly different use of the same technology. So as a gunsmith, pretty regularly I find a piece or a part to a firearm that I need for a project, something that I'm working on for a customer. And that part is either no longer commercially available or cost prohibitive or whatever the case may be, hard to get a hold of. And that slows a project or brings one to a screeching halt. I have pretty regularly had a firearm come in and it needs a piece to make it a complete firearm. In the gunsmithing world, that's what differentiates a gunsmith and an armorer, is the ability to manufacture parts for a firearm, whether using blueprints and schematics or drawings and things of that nature to reproduce a part. Or going off of the void of what is missing and taking measurements and a pen and a piece of paper and basically drawing out what you think will work and machining that and testing it out and going through that process. Well, for the last 100 years, that has been done with the use of conventional machining, primarily in the form of pre-milling machine, a lathe and a shaper, or hand tools, or whatever the case may be. The further we get into an automated world, however, the more of that is done with, the larger portion, we should say, is done with automated machinery, like a CNC machine, and in the case of today's video, 3D printers. So additive manufacturing, by definition, is a process that uses a digital model and creates a physical object by building up layers of whatever the material it is extruding is. There's a little bit more into it now in the world of metal 3D printing. It's not necessarily just building up of layers and extrusion. There are laser printers now and things that some really cool concepts, but in the world of reality that we live in, the majority of us do not have access to $150,000, $200,000 metal 3D printer, but we do have access to a couple of $100 to $300 polymer printer or plastic 3D printer. So, like I said, pretty regularly I find a project that needs a bit or a piece or an odd or an end, and it's usually faster for me to make something, whether it be a prototype to determine that it actually fits the space that I need it to fit and that it does the job that I need it to do, to print one here rather than tying up time in programming and tooling and setup on a CNC machine, like a milling machine or a CNC lathe. In my experience, it's usually faster to go this route, make a small widget, whatever it is, test that it works, or if it needs to be something that's made out of polymer, just make the part. Install it in the firearm and send it on out the door. Until a few years ago, my only experience was with manual machining, running a manual mill and a manual lathe. And then I worked for a gentleman at the time who's a good friend of mine who invested in some automated tooling. And in that tooling was a 5-axis CNC machine, much different field of work than I'm in now, but a same concept, a big gantry mill that was capable of doing 5-axis machining. And so during that process, we went to a school offered by the manufacturer and went through a certification process and learned how to program, but to also understand how three-dimensional objects work and how to teach a machine who basically understands code what it is that you want to produce and drawing that in CAD, putting that through a CAM process to where it basically either builds the layers in the example of a 3D machine or a 3D printer, or understands what needs to be removed from the piece of material that you're starting with. So I fortunately was paid by my employer at the time to learn this process. But my teenager took a class at school to understand how to run one of these. Much more simpler, much smaller, easier digestible learning process. There's a lot of automation that can be done through software. You basically determine what the part is that you need to make, learn how to draw that in CAD with the certain constraints that you need, and then you send the material to the device and slice it to give your layers that you're going to build, and press go, and the machine makes parts. A lot of us think of 3D printing and think of toys and gadgets and gizmos that our kids enjoy, but I personally can attest to the usefulness of it in the gun shop. So the example I have for you today, this is a Ruger old model single six, or a super single six technically. The customer brought the firearm to me. It was in pieces. There was a Ziploc bag full of pieces. He said, I'm certain that things are missing. I don't know what's missing, and I don't know what's needed to put it back together, what's damaged, so on and so forth. And so in diagnosing, taking the parts out and laying them out and determining what's there and not there, I found that the ejector rod for the revolver was damaged. And so the ejector rod looks like this. It is a steel rod with a polymer end on it, and the polymer end was completely missing. And so I pulled up a schematic for the firearm, and I determined what the shape of that piece of polymer was supposed to look like, or in a close approximation, and determined pretty quickly that, for one, it's a very easy part from dimensions to reproduce, but two, it was made originally out of polymer, which is something that I could do here in the shop. So doing my due diligence, trying to save the customer some money, I went online and I looked at all of the part suppliers that I normally order from and found that this ejector rod assembly isn't available. So if you go to numeric.com and you look at parts diagrams for various firearms, this part is no longer in stock and it's not in production, so they don't have new production to fit the old models. And if they did have one in stock, this is a $25 part. So you take $25 cost plus $5 or $10 in shipping, that's $35 to my bench plus the installation for the customer. Whereas it takes me 5-10 minutes in CAD, we'll call it 10 minutes, to measure the part, draw it in CAD, call that 15 minutes total, send the sliced diagram, the G code that I need to the machine, press go, and then I can walk away and go work on something else, assembling the rest of the revolver, metal finish, whatever the case may be. This machine can run in the background. Total investment on this machine, this is an Anycubic. It's a fairly affordable entry-level 3D printer. Call it $250, $300. This machine can run in the background just like this one can, but it takes me 20 minutes to get this set up and running, and it may take me 30, 40, 50 minutes to get this running. And then it needs more babysitting than this does. If that crashes, it costs me a $50, $100 end mill, or jaws on a vise, or whatever the case may be. If it crashes and there's some major encoder error or I damage a piece of it, it's a lot more expensive to fix that than it is this. If this crashes while I'm over sandblasting the rest of the frame of the firearm, it costs me time. And in the event that I were to completely destroy the machine, which is kind of hard to do, these things don't use a lot of force, and so therefore they don't really destroy themselves easily. But worst case scenario, I destroy it, I'm only out $200-300. So I'm very curious to know who else is using 3D printing or additive manufacturing in the gun sphere outside of making 3D printed Glocks and things of that nature. But I'm very curious to know what your thoughts are. I think that this is a technology that is going to see some growth in the next 5 to 10 years, especially with the advent of metal 3D printing. We're already seeing that manufacturers are making suppressors and really hard use hardware items out of some really cool materials with some dimensions and designs that wouldn't be capable of with conventional machining. So I'd love to hear your opinions. Drop a comment down below. Do you think that this 3D printing in its current configuration with polymers and plastics is a viable option for a gunsmith, or do you think that this is still just in the world of hobbies? Thanks for hanging out. Hope you have a great evening.